In today's lesson, we are going to be looking at equivalent equations. So basically, we're going to be looking at different types of equations or equations in different forms, and we're going to ask or we're going to try to determine if they're equivalent or basically if they're the same. And we're going to look at 4 different methods. We're going to look at using algebra tiles, graphing, algebra steps, and verifying numbers. So we have 2 equations here, y equals negative 3x plus 2 and y equals negative 3 times x plus 2 plus 8. So we're going to go through a couple of these different steps. We're going to start with algebra tiles. Now you may not have heard of algebra tiles before, but essentially they're basically like your base 10 cubes, except for when dealing with algebra. So you might be able to get them physically, or if you need digital ones, there are digital ones available at Mathagon. So basically we have a block that represents ones, a block that represents x, a block that represents x squareds, and then again the same thing in the negatives. So what we're going to do is we're going to try to represent the same thing or both equations in the same and see if they're equal. So let me move this off to the side. So I have in the first one y equals negative 3x plus 2. So that means I have plus 2 and I have negative 3x. So that means I have 3 negative x's. So that's the first equation. The second equation is saying I have negative 3 groups of x plus 2. What that means is, instead of saying I have x, saying I have x plus 2, I have negative of that. I have negative 3 groups. So instead of saying like this, that would be positive 3, but I have negative 3 groups. So I actually need to get rid of these and do the negative version. So there's 1 group, there's 2 groups, and there's 3 groups. So there's negative 3 groups of x plus 2. The second thing we can see is we have plus 8. So I need 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1s. So this is the entire equation, right? I have, can't really see it there. Let me bring it there. So we have our one equation here, negative 3x plus 2, and here we have negative 3 times x plus 2 here in the purple, and then the plus 8. We can simplify this a bit because I can cancel some out, because a negative 1 and a positive 1 make 0. And I should be able to see that when I have everything together, it is the exact same equation. I have a negative 3x's, and I have plus 2. So these 2 equations, based on the algebra tiles, are the same. So we can take this image and represent it, or use the algebra tiles, or again the digital version, and we can see that this is equal. If we go to our graphing, we're going to be basically graphing the 2 equations. So in a previous lesson, we talked about graphing. So if I want to graph the first one, and usually we can only really graph it if it's in y equals mx plus b form. So the first one is at plus 2. So I'm going to put a dot at plus 2 for the b value. And the negative 3 means that for every 1 position, I go down 3. So negative 1 at position 1, negative 4 at position 2, and 3 is negative 7. If I reverse it, that means I go up 3 for every position I go back. So this means at negative 1 it's 5, and at negative 2 it's 8. And from there I can graph it. Now the second one is a little bit harder based on what we have, but there is another online tool or another digital tool that we can use to help us graph, and that's going to be Desmos. So for Desmos, basically we go to desmos.com and you should end up at a page that looks like this. Basically it's an online graphing calculator that lets you graph any type of equation. So we're going to click on Graphing Calculator, and over here we're going to enter in our second equation. We're going to enter it in exactly as you see it. You can also use this on your phone, and if you're not too sure about how to enter it, you can also use the keypad at the bottom that does have more of the specific symbols. But you can usually just type it as you see it, y equals -3 bracket x plus 2 bracket plus 8. And from there, we're looking at our graph of the equation. And we can see that it starts at -2. We can see we have a point, if we zoom in, at 1 and -1, at 2 and -4, right? So we can see that we have the same points as the one we've graphed. So based on that, we could say, okay, they are equivalent. The technology shows that this equation graphs the same values that we graphed when we did it by hand. So again, multiple ways that we can do this. In some cases, we are using technology to help us with our graphing. So our last two examples that we're going to look at, we've looked at algebra tiles and found that they're the same. We've looked at graphing both by hand and digitally, and we found that they're the same. Next, we're going to look at algebra steps. And with algebra steps, what we're going to do is basically we're going to use our knowledge of algebra, basically working with equations or expressions, and try to see if we expand or simplify the equations, will they get down to the same? Well, the first equation I don't really have to do anything with. That's already as simplified as it can be. The second equation, however, I can work with and I can simplify, because I should recognize that I have some distributive property here, so I can multiply this -3 through. So this then becomes -3x, -3 times x is -3x, -3 times 2 is -6, and I have the plus 8 at the end. I should then also recognize that I have like terms, the -6 and the plus 8. I can collect those, and I should get -3x plus 2. So in the end, we can see that by using algebra, I do get the exact same value as the other equation. So this does work out, again, in another way to show that I do have the exact same equation. Let me just spread this out a little bit. So that's how you would solve or show that they're equivalent using algebra steps. You would basically be trying to simplify the equation using the algebra concepts that we know. So it might be collecting like terms, distributive property, maybe your power rules or things like that, to simplify it as much as we can. And lastly, verifying numbers. So in other words, you can think of this as plug numbers in. So basically what we're going to be doing is we're going to be plugging in numbers for x and y, for x or just for y, and seeing, do we get the same answer? Now because it's set up to be y equals, basically it's easier to sub in values for x and just see, do we get the same y value? So let's say, for example, we're going to plug in our first one, we'll say x equals 1. Let's just keep it easy. So in this case, in our first one, we have y equals -3 times 1 plus 2. Okay, y equals -3 plus 2. Y equals -1. If we do the same thing with equation 2, y equals -3 times -1 plus 2, and then plus 8. I'm going to simplify my brackets, so negative 3 times 1, or, oops, sorry, not negative 1, positive 1. So negative 3 times 3 plus 8. I get y equals then multiply negative 9 plus 8, and y equals negative 1. So I do get the same answer. Now, we don't have enough space, but we would want to use or try it again with another x value. You want to do at least more than one to make sure it's just not a fluke, right? So you do want to do at least 2, and definitely the more confident you are. So we're going to say at least 2 x values, or 2 different x values. So we want to plug in at least 2 different x values just to make sure that the first time wasn't a fluke, and to make sure that we do get the same thing multiple times, just to reaffirm that they are the same, or maybe that they're not. So again, those are the 4 different ways that we can look at to find if an equation or if a pair of equations are equivalent. 1, using algebra tiles to represent the numbers and the x's and seeing if they work out to the same. 2, graphing. We should be able to graph the one equation by hand. And then the second one, if it's a little bit more complicated, we can use an online graphing calculator such as Desmos and seeing if they're the same. 3, algebra steps. So simplifying both equations using distributive property and collecting like terms to seeing if we get the same equation. And then finally, verifying numbers. So basically you're plugging values in or numbers in, most likely for x, just to make it easier, to see if you get the same y value. And generally speaking, you want to try at least 2 different x values to make sure that you do have the same equation or the same answers coming up multiple times. So again, a little bit of what we've already done, but just using it to verify if 2 equations are the same.